Okay, this is a lecture on chapter 14, Word Perfect. So here we start doing text mining, and processing text requires some more detailed approach that are not necessary in processing numbers. So it's a little bit tricky, and you have to go through some loops. And the main idea of text mining, some of them are covered on the other lecture, but some of them are left out. So I would like to go through those. So major idea is written in the textbook. Something that I want to stress is strings as factors. When you read a text file, for example, I have this text file here in this sample.csv file. For example, I'm just giving you an example. So I always set strings as factors as false. So this is the first thing that you should do. If you don't set this, the read CSV will read letters as if those are factors. So it will block you from doing a further process. So make sure that when you are dealing with text data and when you have to read the CSV file or text file that includes text file that you want to process, make sure that you have you set strings as factors as false. Let me see how, when you don't set it, how it read the letters. Oh, okay. Structure, let's do structure. So it is a data frame, and the major text file is here. This is text column, and look at this. It read it as if it is factor, but you want it as a characters, not as factors. Factors are, you know what the factor variable is. Letters are not factor variables, so that's why we set it strings as factors as false. Then let's see if you see the text, it read it as character file. So that's one thing that I want to stress. It is on the textbook. And another thing is in the textbook you can follow the textbook basically. However, the textbook assumes that you have this text file called sva.txt, but we don't. So I will go through the process that you can create that text file. It's a little tricky because you have to go through this is basically web scraping and then cleaning the results. Sometimes this will be very useful for you to know. That's why I'm going through it. First process is use URL encode function and then read the URL. So what would SVA location? It is just a text file that includes the URL. And then now, so you have a URL saved in an object, and let's use HTML tree parse function. So I'm not sure how many of you took web development at this point, and if you didn't, I strongly recommend you to take it. Because it's very useful to understand HTML and JavaScript. That will make you more comparative. And another thing is like this, you need to understand HTML structure, which is not very complicated. Let me show you how it looks like. So this is the URL that we have put. So this is the file, and this is of course HTML. If you go to view page source, then it gives you this HTML code and how all the text is coded. So basically what it does is it will read this each node HTML code as a tree type, so that you can extract, in this case, only P. P include paragraph that include the major sentences only. We don't need other stuff, but we only need things, text that are included in P, paragraph. So what it does is it set up the structure using this. Let's see what that look like. Look, so you have read all as was organized as HTML structure, and what we need is we only read through things that are included in P, and then those sentences. That's what we want. So we want to extract only those part here, and then save it as SVA, and then SVA looks like this. So it's getting close to like text format. So at this point you could save it as a text file, right? That so it is now text file that was saved as if it is text file. So based on that, you can go through the next process, and these are all explained in the video. But let's see. So this process is this is just the simple memorization requires, because to process text in a go through it, you have to format it in a specific specific format, and the vector source and corpus are two functions that will transfer this text file in a more possible format to do the text analysis. So using corpus function, let's transform it to different format. And let's see, a vector source. I will show you the structure of words as a vector. So this way, first of all, it was text file that didn't have was not organized as vectors, but you have to transfer it to vector first. So now this is a vector that includes each sentence in each spot, and then the next process is put it as a corpus format. So that's the two extra steps that you have to go through. And once it is organized as the corpus type, then you can do further processing, cleaning, changing everything to lower, and then remove punctuation. So TM map function is very useful to cleaning the data set. Just to show you words corpus. Now words corpus, it looks like this. It's a list and what we need is these text files only. So if you look at this, it has capitals and then punctuations included. First thing is to do anything you want to do, switch everything to lowercase. So if you run it, everything is now changed to lower. And then now let's get rid of punctuation. Now punctuation is gone. And then we can get rid of numbers because we don't need numbers. And then the next step is you see this stop words here and there that appears in almost all the sentences, but it doesn't have information value to us. So the next step is eliminating all those stop words from there. So you run it, and let's see here, I, you, and those terms are all gone now. So it's ready for any type of processing. And term document matrix is the thing that we usually use for any kind of frequency calculation. What it does is it makes this vector of words to matrix where terms are on the rows and let's see, yeah, terms are on the rows and documents are on the columns, and it calculates how many times that term occur in a document. Let's see, actually. So here, terms are on the left side, so it includes all the unique terms that appeared in the corpus. And then documents is, we have how many documents? We have 16 documents. So it has 16 documents as a column. And then each cell includes how many times this term occurred in specific document. And then, so once that term document is organized as a data frame, we have to switch it to matrix for more processing. And then so it's the formula. The type is almost looks the same as a TDM and M, but it's just the type is from data frame to term document matrix to a matrix here in M, so that you can do mathematical calculation using matrix format. So what you want to do is you want to add up all the instances where this term happened in each sentence in this case. Then you can calculate how many, the frequency of each term. That's what it does. This one, row sums function, is summing up every incidence has happened on that row. So let's run it, and then it has per each character it includes how many times it occurred. So now so this is how it looked like for each term. It shows how many times it occurred in the entire sentences in the corpus. So next one is you want to sort the word counts by this decreasing order. So let's see, word counts. So now the most frequent one comes first. So now you're really ready. The most popular one. So bring word cloud package, and then that word cloud takes data frame. So you need to transform this to data frame again. So and one is the create columns, one is word, and the other column is frequency, column. And then if you just see how it looked like, now it's a data frame with the word and then frequency count there. So, and then using word count function, you can create word cloud. And the other thing that you can do is find association of specific term. In this case, woman was the most popular term, and you can find any term that co-occurred with woman in 60% of chance, or something like that, over than that. So yeah, it occurred with this type of terms. Then you can understand what kind of terms were used together. Let's see, how about based on the word count, you can test. How about war? Is it Adolf Hitler? Hitler, that comes with a war a lot. So this is how you Abraham has something to do with the war too, and genocide. So this is how you use the basic word count and word cloud, and find association between terms. Okay, so this is the end of the lecture for chapter 14.